So hi guys, this is Jeffrey. So we're gonna do our Algebra 2 and we are on Unit 7. So this will be the last section, Advanced Interpretation of Exponential Models. So this is the last section of interpretation of exponential models. So if you're not familiar with exponential numbers or expressions or graphing functions, and that could be on the other episode, or you can contact me. Okay, so the interpretation of the models are always about the English translating that to mathematical expression, right? Like this models right here, and sometimes it's gonna be the other way around, right? So the models and you translate back into the statements. Okay, so in this case we have sunfish, and this is the elapsed time, t is right here, and you got the result as the mass of the whole bunch of fish that is born. Okay, so every day there is a how many percentage addition to the mass of the sunfish. That is the question, right? So remember, addition to, so we're gonna get rid of the original one, right? So if you plug in the 0, of course this is gonna be 1, and then this is gonna be the original numbers that you have, right? 1.35 to the power of 5. But we are kind of not interested in that because we divided to find the next, because it's geometric series or sequence. So the next like the number 1 day is what we are interested in, right? Because we can see this model is increasing in a geometric way. All right, so we plug in the 1 and then we find the next sequence number. All right, so 1 is gonna be 1.35. It's right here, 1.35 to the power of 1 divided by 6, right? So this is our number. So it says round your numbers to the nearest percentage. So remember to get rid of the original, which is the 1, and the ones that you're growing from, the population that you're growing from, or milligrams that you're growing from, does not matter because we're interested in that addition, right? So it's gonna be 5%. Okay, 5%. 5%. Okay, so let's go for another model here. Okay, so the other model is going to be the amount of carbon dioxide, okay, CO2. So let's see the original. The original CO2 is, I guess this is in decade. Okay, so the time elapsed is in decades. So we're gonna think of it as 1/10, right? If you want to increase by only 1 year, because a decade is 10 years. So if you elapse over 10 years, then 1 year will be 1/10. Okay, and this is the atmosphere. So that's our result in parts per million. Okay, and this is our model right here. So every year, the question is asking us every year the amount of CO2 in the atmosphere increased by a factor of how much. So originally supposedly it's going to be 315, but this is the geometric series where you increase by that much every 10 years, but we're going to convert that into 1 year, so it's 1/10. So you plug in the 1/10 here, you're gonna see that factor right here. So the whole thing is the factor, right? So you're not gonna plug in 1 because 1 meaning in this case decades, right? But the question is asking you about the yearly rate, so you're gonna divide by 10. Alright, so let's do that right now. 1.06 to the power of 1 over 10. Okay, that's gonna be 0.5, 1.005. Okay, 2 decimal places. Round your answer to the 2 decimal places. So it's gonna be 1.01. Alright. Two decimal places. Okay, so that's 4 decimal places, but it's alright.